In this video, we are going to talk about the examples of the trigonometric function. So, as you can see, the example is if sine theta is equal to 5 over 13, find other trigonometric ratios. So, as you can see, it is given that sine theta is 5 over 13. Now, what is sine angle, or I should say what is trigonometric ratio sine? And if you remember correctly, sine was basically opposite over hypotenuse. So sine was basically opposite over hypotenuse. So if I want to find the other trigonometric ratios, we need to use the given sides of the triangle. So as you can see, my opposite is 5 and my hypotenuse I can take as 13 units. So what I'm going to do, I'm going to draw a right triangle. So this is the right triangle. And I'm going to consider this angle as 90 degree. So if this angle is 90 degree, then the name of the side opposite to this angle would be this side, and that will be hypotenuse. 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 So this would be my hypotenuse. And I'm going to consider my reference angle, as you can see, which is theta. So if I take this angle as my reference angle theta, then the side opposite to the reference angle is basically this side. So that side will be what? Opposite. And side next to reference angle is this side, and that side will be adjacent. Now let's see what is given in the question. So as you can see, opposite is given 5 units. So my opposite is 5 and my hypotenuse is 13. So this side is basically 13. This side right here. Now we don't know what adjacent is, but we know what a Pythagorean theorem is. So what I'm going to do, I'm going to write the sides as A, B, and C. So basically I can write this is my C, because hypotenuse is always C, and it doesn't matter to me which one is A and which one is B. So I'm going to take this one as small a and adjacent is small b. And as you can see, I don't know the adjacent. But my Pythagorean theorem is Pythagorean. Pythagorean theorem is basically c squared is equal to a squared plus b squared, and as you can see, my a is opposite, which is 5, so I will write 5 squared plus my b I don't know, so I'm going to write b as b, so b squared, and my c is hypotenuse, which is 13, so I will write 13 squared. So the square of 13 is 169, that is equal to square of 5 is 25 plus b squared. I want to find the value of b squared. So what I'm going to do, I'm going to subtract 25 from both sides so that I can separate b squared from the numbers. So if I do that, I will subtract 25, so this will be cancelled out, and only thing left on the right side is b squared, that is equal to 169 minus 25. So let's subtract. So 9 minus 5 is 4, 6 minus 2 is again 4, and then 1 is left over. Now we need to find the value of b. So what I'm going to do, I'm going to take the square root on both sides. So square root of b squared is b, and the square root of 144 is 12. So as we can see, my B is 12 units. And what I'm going to do, I'm going to place that over here. So this will be my 12 now. Alright? So as you can see, I got everything done on my triangle. So now let's talk about the trigonometric ratios. So the first trigonometric ratio that we want to talk about is sine of theta, which is given, and that is given as 5/13. We know that the reciprocal of sine is cosecant. So the reciprocal of sine is cosecant, so I need to find the reciprocal of 5/13, so I need to flip it. And if I flip it, I will write 13/5. Right? Pretty simple, huh? Now, the next thing that I want to talk about is cosine. Cosine theta is, if you remember, cosine is adjacent over hypotenuse. So my adjacent is 12 and my hypotenuse is 13. So cosine theta is 12/13. So I can write cosine theta is 12/13. And the trigonometric ratio, that is reciprocal of cosine, is secant. So that will be secant theta. And the reciprocal of cosine is secant. So I need to do the reciprocal of 12/13. And when I flip it, I will get my reciprocal. So when we flip it, we can write 13/12. So my cosine is 12/13 and my secant is 13/12. Now, the last trigonometric ratio that we have is tangent. And we know tangent is opposite over adjacent. And as you can see, my opposite is 5 and my adjacent is 12. So I can write tangent theta is opposite over adjacent, which is basically what? 5/12. And the reciprocal of tangent is basically cotangent. So I write cotangent of theta. And since we are finding the reciprocal of tangent, we will flip 5/12 to find the reciprocal. So if I flip 5/12, I will get 12/5. So as you can see, my trigonometric ratio sine is given, which is 5/13. Cosecant is 13/5. And it's kind of easy to find the cosecant from sine because they are reciprocal of each other. We got cosine as 12/13 and the reciprocal of cosine is secant. So the secant will be 13/12. And as you can see, my tangent is 5/12 and my cotangent is 12/5 because tangent is reciprocal of cotangent and cotangent is reciprocal of tangent. So if I know tangent, I can find cotangent. So as you can see, I have all my 6 trigonometric ratios and only thing given was one trigonometric ratio, which was sine. So basically, we can use that trigonometric ratio to find the given side, and then we can also find the missing side, and then we can use the right triangle, like using the Pythagorean theorem, to find the missing side and find all the 6 trigonometric ratios such as sine, cosecant, cosine, secant, tangent and cotangent.